Hi, I'm Willie Proshek. I am an AI engineer and Udacity graduate. I've completed the Deep Learning, Artificial Intelligence Engineer and Deep Reinforcement Learning Expert Nano degrees. I will be your mentor for this course and I'm excited to get started to achieve your goals. It is a fantastic course with great content and fantastic projects that will get you used to real-world problems. Before I go any further, I would like to give you a bit of a background on myself. I'm a system engineer by trade and have transitioned over to AI in the last few years. I run an AI startup that specialises in deep reinforcement learning, and what inspired me to get into the field in the beginning was I saw Pong from Pixels by Karpathy, look it up if you haven't seen it, and also the Deep Q network by DeepMind. So when they were able to do human level or better results in Atari games. I also believe that deep reinforcement learning as a technology has the greatest capabilities to change the world for the better. And the more people that can learn this technology, the more we can fix the problems that we will be facing. A bit about my personal, I like gardening, I like skating, I like coffee, I like music, and I like spending time with my family. What I'd like you all to do now is to introduce yourselves, and before that think about what your goals are out of this course. So what do you want to achieve and what inspired you to do it in the first place, and just give us a bit of a background on yourself. We'll be working together, all on the same task of completing this course successfully and applying what we've learned, and the more we understand each other, the more we can help, and the more I can help you. So if one of you would like to start, that would be fantastic. Now that we've listened to why and been introduced to everyone, I will now go on to the course, this session's material. So in this session, I'm just going to cover just an introduction to deep reinforcement learning, go over the course itself, and also tips and tricks that I learned from doing the course. The final thing that I'll go through is just some additional resources. So deep reinforcement learning. Look, deep reinforcement learning combines multiple technologies, predominantly deep learning and reinforcement learning. The deep uses deep learning, and the reinforcement learning, of course, is reinforcement learning. It is a subset of artificial intelligence and a subset of machine learning. Machine learning is broken into three main parts, which is supervised learning, unsupervised learning, and reinforcement learning. Supervisory learning is probably what most people know of, so that involves labelled data, while supervised learning is unlabelled data and usually is trying to actually find patterns in the data or groupings. Reinforcement learning is a type of machine learning technique that enables an agent to learn an interactive environment by trial and error using feedback from its own actions and experiences. And deep learning is using neural networks or layers of neural networks. Basically, what makes deep reinforcement learning different to reinforcement learning is using a deep neural network as a policy. Traditional reinforcement learning uses a tabular format, which means that if it wants to find a solution to a problem, it has to explore every single state and action. With deep reinforcement learning, this allows us to generalize better, which means that we don't have to see every state. And in some things, you'll never see all states, or it's completely impossible. For example, every single possibility of a Go board. The application of deep reinforcement learning is many. It can be used for finance, robotics, automation, agriculture, basically anything you can think of, we can apply it in some way to optimize a reward. Now, This slide on the left shows the agent environment loop, which is the core to reinforcement learning. You predominantly are learning reinforcement learning in this course with the deep learning attached to it. But the core of it is reinforcement learning. So at each time step, the agent performs an action. The environment then transitions to the next step and provides the next state and reward to the agent. What the agent is actually trying to achieve is to maximize that cumulative reward, or the expected sum of reward attained over all steps. On the right hand side explains that same process using an Atari game. So the agent would, the brain represents the agent. It performs an action, which is one of the buttons on the Atari console or controller. It goes to the console and game, which is the environment, which then sends back pixels as the state and the reward, which is the score. What it's basically trying to do is maximize that score, and so it tries different actions and optimizes that over time. The other thing that you'll be probably looking at is episodic continuous task. An episodic task basically would be, for example, a game of chess, the start to the finish. A continuous task continue forever without an end. One of the main important things with reinforcement learning is the reward hypothesis. So all goals can be framed as a maximization of expected cumulative reward. Probably the other thing is discounted return, and probably what I think is very important to get your head around is the Markov decision process and one-step dynamics. Make sure that in the first part of the course you really get that down packed, because it is very important in how that you frame a deep RL problem. So next, now before we go to anything else, I'd just like to give you some links to some cool things to inspire you. One of the things which is the Alpha Star, which is DeepMind's agent or bot which plays StarCraft 2. It was able to beat two of the top professional players in a 5v5. It shows the capabilities of what can be achieved, and this is only last week that this pretty much was released. Other things that I would look at would be all of basically DeepMind stuff, so AlphaGo, AlphaFold, AlphaZero, and also look up the movie AlphaGo. It's a documentary on them, how they achieved beating the best professional Go player, and great movie to watch, and will inspire you in more in the field. Another thing would be OpenAI 5. If anyone's played Dota and understands how crazy the professional league is, to be able to beat some of those players is an incredible feat. In 1v1 it did incredibly well. In 5v5 it struggled a little bit, but achieved incredible results, and all it needs is more training. The more it trains, the better it will become. So next, the course itself is broken down into 4 parts: introduction to deep reinforcement learning, value-based methods, policy-based methods, and multi-agent reinforcement learning. Pretty much the introduction will give you an idea of reinforcement learning, and that's the foundations that you'll build upon for everything else in this course. So I highly recommend going over it, and if you finish the course material, go over it again. You've got about 4 weeks set aside for this, and it is critical to understand. You will learn Monte Carlo methods, temporal difference methods, continuous spaces, a bit of everything, but Markov decision process is probably the most important thing to get your head around. With value-based methods, this is when you get your first project, and you'll learn about deep queue networks and rainbow networks and all the different features of that. The first project is a 3D maze and basically collecting bananas. It's a great project and I really enjoyed it. The third part of the course is policy-based methods. Policy-based methods are becoming really hot right now, especially the actor-critic methods and proximal policy optimization, or PPO. That's my go-to algorithm. That with an LSTM is very powerful and very easy to implement. You'll really enjoy this section, and the project is really good as well. The last section is multi-agent reinforcement learning. So one of the important factors is being able to get multiple agents working together, either as collaboration or in competition to achieve a goal. Typically, most reinforcement learning algorithms use a single agent, and this is something that the field has been pushing hard over the last 12 to 18 months to start getting better at multi-agent problems. Now, before I go any further, if you've got any questions on both the introduction and also the course, I'd like you to ask them now before we move forwards. Okay, we'll move on to the next step. Now, some tips and tricks that I would give you is when you send in your project, if you don't pass it the first time, the reviews are all positive. There's nothing negative about not passing. It just means that you've learned another way of not doing it, a bit like reinforcement learning. You try again. But listen to that feedback. The mentors, reviewers all want you to succeed. We want you to be able to apply this in the field and be, that's the whole reason of doing this. If you get stuck, go to Slack, talk to mentors, go to the student hub, go to the knowledge base, and what I highly recommend is going through the examples on GitHub. Most of the projects, there's examples that have been provided through the course material, which will give you a very good understanding of how to apply it to your project. So if you want to apply a deep query network, find an example with a deep query network and read through the code and make sure you understand it. The other thing I tend to do, and this may work for me and may not work for you, is I look at the projects the moment they're available. So they're in the back of my mind. So when I'm going through the course material, I can sort of check off things that I might need to apply to it. I find that I go back to the course material over and over again, but this definitely helps. The other thing which I would recommend is print out the rubric, and before you submit, make sure that everything can be ticked off. If it can be ticked off, you'll pass the project, and it's an easy way to make sure you've satisfied all the criteria. The other thing which I would recommend is the cheat sheet for this course. Go print it out once again and go over it for 3 to 5 minutes every day. Use someone else maybe to ask you questions on it, because it will make you understand the algorithms and notation much clearer. It may look like hieroglyphs at the beginning, but the more you look at it, the more it will make sense. The other thing is stay focused. The reason why I said at the beginning is to think about what inspired you and what your end goal is that when it gets hard, because it will get hard, it's a challenging advanced course, that you can go, all right, that's why I'm doing it, that's why I want to do it, that's why I'm pushing for this. So stay focused, and if you get stuck, contact myself or fellow students, and most people will be, and myself especially, will be glad to help. Finally, I've just given you some resources to look through. The Growing Deep Reinforcement Learning book is great. I recommend purchasing it. You get 50% discount being an Udacity student. And basically some additional code bases to look at. So go through that information and click them all and see what you can find. So pretty much that's all I have time for today. Thank you very much for listening, and I can't wait to get into the course further, and so we can achieve everyone's goals. Thank you very much, and until next time.